You can pause the video and attempt this question yourselves, but otherwise I shall process this information first. They say that HEJG, so look for that figure. So that's the inside quadrilateral, is a parallelogram. So I'm going to process that information. So I know that the opposite sides of a parallelogram are congruent. So I'm using parallelogram properties. I also know that the diagonal AJ bisects this parallelogram into two congruent triangles, and then I can form alternate interior angles like this. So we know that angle 1 equals angle 2. Okay, because these sides HG, repeat, HG and EJ are parallel, you can form a Z. So the vertex angles of the Z are congruent. Similarly, I can do that angle, let's call it 3, is equal to 4. Again, these are alternate interior angles because HE, repeat, HE is parallel to GJ. Okay, so those are parallelogram properties. We also know the opposite angles of a parallelogram are congruent. So I know also, let's say 5, angle 5 is congruent to angle 6. Okay. Now, I do not know what information is actually going to be used for this question, but I'm just processing the given information. They also say that angle, so the second guy, okay, angle DGH, okay, that's this guy. Okay, I'll use a different color. So this guy, let's call this guy 7, is congruent to angle FEJ. FEJ, okay, that's that guy here. So let's say 8. So this is all the information we are given, or we could conclude, or we could infer from the given information. And the question says prove that DEFG, so DEFG, so that's the big quadrilateral, is a parallelogram. All right. I just switched to black ink. So you can pause the video and have an independent shot of the problem. Otherwise, here's what my approach will be. There's no one right way to do the problem. Okay, there are several approaches. If I can show that this triangle over here is congruent to this triangle over here, then I can, so that's my initial objective. Okay, my goal 1 is going to be to show that triangle DGH is congruent to triangle FEJ. Okay, FEJ. So that's my first goal. My philosophy, or rather approach, is that if I can show these two triangles are congruent, then corresponding parts of congruent triangles are congruent, and then from there I can move forwards and show that the opposite sides of this figure are congruent. I can also demonstrate, because I have a diagonal DF, I can also demonstrate that the corner angles are, say, over here. I'll even label this here. So I'll use a different ink so I can show you what I'm going to demonstrate. I can demonstrate then that 9 is congruent to 10, which is here. If I can demonstrate 9 is congruent to 10, then I will then show that the two sides DG and EF, repeat, DG and EF, are parallel, because 9 and 10 are alternate interior angles. And there's a theorem that says if one pair of opposite sides are both parallel and congruent, okay, one pair of opposite sides are both, in a quadrilateral, are both parallel and congruent, then the quadrilateral is a parallelogram. So I'll be using that approach. So anyway, so my first goal is to show that these two highlighted triangles are congruent. So let's have a go at this. I already know that angle 7 equals angle 8. So I have one angle of each triangle congruent to each other. I also know that HG is congruent to EJ. Okay. So I just have to demonstrate a third angle is congruent. Now I know that angle 1 equals angle 2. And this whole angle, just choose a highlighter, this whole angle over here is basically 180 degrees, and so is this guy. Okay, both are 180 degrees, and we know that angle 1 equals angle 2. So therefore I can show, so I'm going to use a different pen, just a different color, so I can show you what I'm trying to do. Therefore I can show that angle 10, angle 11 equals angle 12. Okay, I can show that angle 11 equals angle 12 very easily. So that'll be my starting point. So we first we know that angle 7 equals angle, or is congruent to angle 8. Okay, that was given. We also know that HG is congruent to JE. So we know the opposite sides of a parallelogram. We're talking of H, E, JG, sorry, are congruent. And then finally, we know, or we can demonstrate, that angle 11 is congruent to angle 12, because 180 degrees minus angle 1 should be congruent to 180 degrees minus angle 2. So we know that angle 11 equals angle 12. Therefore, the two triangles are congruent by angle side angle. Okay, this is not the only approach. There may be easier approaches, but this kind of naturally occurs to me. Now that I know the two triangles are congruent, I can go from there. I can demonstrate that therefore angle 9 is congruent to angle 10. Okay, which is the corresponding parts of congruent triangles are congruent. All right. And since angle 9 equals angle 10, but angle 9 and angle 10 are actually alternate interior angles. Okay, if you observe. And since angle 9 equals angle 10, and they're the alternate interior angles of these two lines, or basically the figure GDFE. Okay, repeat, GDFE. Therefore, we can say that GD is parallel to EF. Okay, basically the alternate interior angle converse theorem. And then last step, we also have DG is congruent to FE, CPCTC. Corresponding parts of congruent triangles are congruent. All right. So we now have demonstrated, that these two sides, I should use 3 dashes. Okay, these two sides are both parallel and congruent. Okay, so we have demonstrated the parallel and congruent. Therefore, DEFG is a parallelogram. Okay, we're basically using the theorem if one pair of opposite sides of a quadrilateral, I'm running out of room, is parallel and congruent, then the quadrilateral is a parallelogram.